Okay, so let's see if we can get this working. So what should be first here? Which color? Okay, the purple, the doc type should be first. Yep. So I'll just drag it up there. What color would be next? Yep. So our opening HTML tag would go underneath the doc type. Yep, so the opening head tag. We've got purple, orange, then blue. What's next? Yep, the title should go inside the head. Next would be what? After the title? Not quite. Yeah, the end head is actually where it needs to be. We don't need to move it. Okay, so yeah, then we've got the body. What color would be next? Yeah, the yellow, the opening PHP tag could go here. And then what? Would be the first thing inside those PHP tags? Actually, no, that's going to go a little bit later. Right. This is the key line in the whole file. This is where we attempt to connect to the database. So we're trying to create a connection. I've created a variable called DB, and we're attempting to make a new connection. We'll talk about this line a bit more in a minute. We'll put the rest of it in order. So what color would be next? Yeah, the red is in the right place where we're checking, do we have a connection, yes or no? And what would come after the red block? Yeah, the bright green at the bottom, there's our else. So if we have no connection, print a message saying there isn't one. And if there is a connection, print a success message. What would come next? That's right. So what do you suppose is happening there where we're making that variable equal to null? Yeah, we're closing the connection. This is really important. Our page would still work without this line, but this is really important for performance. Why do you suppose it would be so important, particularly in a web application, to close a database connection when we're done using it? Potentially, how many users could you have on your website at one time? Yeah, an unlimited number in theory. Right? The web server and database server, they're only going to have so many connections available, so many threads that those processors can handle. So if those processors can handle, let's say, 10,000 connections at once, and we have 10,000 users on the site, loading pages that are talking to the database, what's going to happen when the 10,001st person comes to our website and tries to load a page that uses the database? What kind of response will they see in their browser? If there's no connections available, they'll see this. The page is just going to wait to load until somebody's connection ends. Now, if we open a connection, eventually they'll time out, but they don't time out quickly. So if we open a connection and we don't explicitly close it by setting it to null, that connection is going to stay open for a while. So if our site gets busy, it's going to slow down and people are going to be waiting. So we should always be closing these connections as soon as we're done with them. Okay, so what comes next? Yeah, we'll just close the server-side script, and we can swap these two tags around. So there's our complete code. Start out with the HTML header and body, open some PHP tags, try to connect to the database, determine if it worked or not, disconnect, close our script, and end our page. So in here, it's a little hard to see more. There's a few things happening in this connection. So we're creating a variable. We've also got this new term, we haven't seen this before, PDO. PDO stands for PHP Data Objects. It's the data access library that PHP uses to connect to any kind of database. Okay? PDO has been around for a few years now. It's now the standard database access method for having a PHP application connect to a database. If you look at some code samples online, you may see other connections that don't use PDO. Before PDO came out, the most common library was called MySQLi. Some of the students in my class yesterday had some working code samples with MySQLi. It still works. It's not recommended anymore. So you may see it if you're looking at older videos or tutorials. And the big drawback of MySQLi is it only lets us use a MySQL database. It doesn't let us use PHP with any other kind of database. PDO doesn't care what kind of database we have. We can connect to anything with it. So when we create our PDO object, there's 5 parameters, 5 pieces of information we're passing to it. The first one is, what's the database type? So in our course, we're only ever using MySQL. But if we were using a different type of database, this first parameter would be something else. And then it's our 4 regular parameters we need to connect to a database. The server name or IP, the database name, the username, and password. And in our case, in your case, if you're using your AWS database, the database name and your username are the same. Okay, so let's grab all this code and copy it. I'm going to open up my htdocs folder. I'm going to make a new folder in here for our little music library application. So inside of your htdocs, make a new folder. I'll just call it music library. And then I'm going to open up this folder in my code editor. So pretty much all the files we create the rest of the semester, they'll live inside this folder. I'm going to open up PHP, or open up Visual Studio Code, brackets, Atom, whatever editor you're using. So it will default to our project from last week. So I'm going to open up my, often you have to hit refresh here. So here's my music library folder. So I'm going to open up this folder. It's empty. And then I'm going to make a new PHP file. I'll call this file connection test.php. And we'll try out all the code we just reorganized in that Word document. So I'm going to blank file here. I'll just take out all the code. I'll go back to my Word document now that it's in the right order. I'm going to copy everything. I will dump it in here. Now, if we run the file like this, obviously, we're going to get a message saying could not connect because the credentials aren't filled out. So you've got two choices for the credentials. If you are able to connect to your AWS database, then you can use those credentials. So the same credentials you have in MySQL Workbench. So the host would be aws.computerstudies, spelled this way. Your username. I have to check mine because I never remember it. And your database password. I will also show you if you're using my shared database. I'll show you that connection. So this would be my AWS connection. Yes, I know I'm publishing my password. You have your own database. Don't use mine. Don't break my database. I will be angry. So there's our connection for AWS. If you are using my shared database today on my Loosefoot hosting account, then here's what you need. You need MySQL 7, loosefoot.com. The database name, the username, and a simple password. So you can use either your own AWS account with your credential, or you can use our shared database. You could also, if you like, you could use your local MySQL server. The problem is, once we upload our PHP pages, they can't connect to the database anymore. So this is why it's often a good idea to use an online database. If we're only working locally, things will work on our local server, but you can't run anything on a live web server this way. So it's probably advisable to use either the AWS database or, for today, use my own shared database. So I'll just comment one of these. So I'll save my file. And now I want to serve this page first from my local web server and see if I can connect to the database. If I can, I'll then try uploading the file to the web server and make sure we can connect from the live web server as well. I'm going to open up my XAMPP control panel. I'm going to start my local Apache server. And then I can try and open my file. And this file lives inside my music library folder. So when I run that code, it tries to connect. I've commented out my Loosefoot connection. I've enabled my AWS connection, and I get this message that I'm connected. I'll try the other connection as well. I'll comment out my first one. So you don't need two connections, just use one of them. I should be able to connect to either one of these. So if I refresh, I'm now connected to my Loosefoot server instead. So if you can connect to your AWS, that's better, because you can control that. If you can't connect to AWS for today, please just connect to mine on Loosefoot. One thing to note, this confused a few students yesterday. Where you see this text kind of with a gray background, this is just code hinting from WebStorm. This is not my code. So I had a student yesterday who said I'm getting errors, and he was actually typing the words DSN, username, and password. So wherever you see that little gray shading, those are just parameter prompts from me. It's not my. So everybody should be able to run this file from their local server using one of these connections, and they should be able to get a message saying connected to the database. You don't have to run MySQL because we're not using the local database. You only need to start the MySQL server if your database is local. We're using online databases instead. So now I want to upload this file to AWS and try it there as well. So I'll open up FileZilla. I'm going to use my old FTP connection because it still seems to work. And just a reminder, when you're uploading to the web server, all your files have to go inside of the public HTML folder. If you put them outside, you can't open them in the browser. So over here on the left, I'm inside my htdocs folder. This is my local file system. Over on the right is the AWS file system. I'm just going to upload my music library folder. So that includes my PHP file I just created. So here it is, the file's running locally. I'm now going to go to my AWS site, which is aws.computer studies, and then your GC and your student number. I'm going to try and load the live version of the page as well. That's interesting. Here's my oh, I'm in the wrong. It would help if I went to the right account. Okay. So here's my file. So it's this, I have two versions of the file now. I've got a local version. It can connect to the database. I can upload that file to the live web server. It can connect as well. Again, here's all the code. So all I did was copy the Word document and put in a valid set of credentials for the database connection line. If you can't get it to run, if it runs locally today, but you can't connect to FTP and can't put it up on the web server, that's fine. That's fine too. Doesn't really matter. It's just faster to use the local web server because when we use the local web server, we can just save our change, go back to the browser and hit refresh. If it's running live, it adds one more step that you have to save your change, re-upload the file first, and then refresh to see your changes. So running it on the web server just adds one more step to the process. But if that's working, that's okay. So we want to build a form so we can start saving information to the database, but right now our database is empty. There are no tables in there. So if you're using your own AWS database, I've put a script on D2L that I want you to run in your database to create a table in there. So in the lesson 2 folder, underneath that connection exercise, there's this code. You can ignore this line. We want to copy from here down the create table, the alter table, and the describe table command. I'll show you how to do this in your AWS database. If you're connected to the Loosefoot database, don't do any of this. Just watch. I'll do this in the database. We don't all need to create the same table with the same name. So copy those 3 commands, the create, alter, and describe. First, I'll do it in my AWS database. Then I'll do this in my Loosefoot database. Let's see. So if you are able to connect to your AWS database, first you need to run a use command with your AWS username. Then we can copy and paste those 3 commands I put on D2L. Create the table, change the ID, the starting ID number from 1 to 10,000, and then describe the table. So let's have a look at the structure. So this is the AWS version. I'll just click execute. I get 4 green check marks down at the bottom. It says my table was created. The ID number, starting number was changed to 10,000. And when I describe the table, it gives me 4 columns: an ID, a name, a year founded, and a website. So you only need to do this once. Now we have a container, a place where we can start saving artist data. Now I need to run the same script in the Loosefoot database for anybody who's using that database for today. Anybody who's having issues accessing AWS. So I'm going to open up wrong database. So I'm going to create the exact same table in the shared database on Loosefoot. So you don't need to do this. I'll run the command here. So now I've got 2 different databases with the same table structure in both. So our table's got 4 fields. It's got an artist ID, which is going to be numeric, and those values are automatically assigned by the database. You guys will talk about this, or you did this already. I forgot I keep forgetting you've already done relational database. So there should be nothing new here. I assume everything here is stuff you've seen before. Let the database assign the ID, a string for name, a string for website, a number for year founded. Only the name is required. We don't have to put in the other values. So what we want to now build is an HTML form that has inputs for name, year, and website, and then a PHP page that will process that form, connect to our database, and insert the values. So we need 2 pages to do this. The database or the web server? Access denied. You're trying to connect to AWS or to my shared database? Okay, if you have any problem connecting to AWS today, then please use the shared database that I have put in here. Please use this one for today if you have any problem connecting to AWS. Let's go back to the connection. Close this tab, go back to the main screen. Let's go back to your list of connections. Okay, hit edit connection. Storing keychain. Put the password in again. And let's try test. So you're connected now. You don't need to run the script in this database because I already ran it. The database already has the table we need. So we're using the same database now. I've already built what we need in this database. So we're going to make a new PHP file in our application. Let's call this artist.php. So this is going to include a form where a user can enter new artist data and we can save it to the database. So the first thing we need is a form opening and closing HTML form tag. Right, we talked about this last week. Okay. Okay, here's how to do it. First of all, if you're in WebStorm, if you right-click and choose New HTML File. Sorry, hang on. No, there's another way of doing it. Bear with me for a second. I haven't done this for a while, so I just have to find where it is. Okay. I think here's how to do it. If you're using WebStorm, if you click on File and Settings, and in the search box at the top, you search for the word template. Sorry? I have to, that wasn't the right screen, so that's why I closed it. Okay, so from here, sorry, I had it, and now it's taking me somewhere else. Okay, so You click on Appearance at the top and search for templates. And down here under Editor, it brings up this item, File and Code Templates. So the first item here should say HTML file, I believe. So if you copy that, highlight what's here, and copy it. And then about 10 items down, here's the PHP file template. So if you click on that, yours is probably empty. Like this box here, there's maybe just a set of PHP tags. So what I would do is paste in the HTML template and just take out the title here that's got anything that's got the pound signs around it. Take out the title and the body. So we're basically copying the HTML template to the PHP template. So again, if you're in WebStorm, click File and Settings and search for templates in the search box. And that should bring up the File and Code Templates section on the left. And then we're copying the HTML template into the PHP template. And I just removed those two dynamic items with the pound signs around them. Jillian, did that work? If you make a PHP file, you now get the right HTML template? Okay. Okay, that's... So now inside our form, we need to add some form inputs. We need to give the users inputs for name, year, and website. And every input is going to have a label beside it that tells the user what the boxes are. We can't just give them 3 empty boxes. So what we want to do is we want to group each input with a label. And HTML has this field set tag. Basically break them up into lines with borders around them. So our first label will say name. And there's our first input. So it's a good idea to use the same value for name, ID, and the name of our column in the database. Match them exactly. So that'll give us one text box called name. So if I want to open my file in the browser, I load my artist file. So the field set gives it a border label next to the text box. So we want to add 2 more field sets, one for the year and one for the website. Actually, I don't think I called the column year in my database. I called the column year founded in camel case. So I'm going to use the same name here. So now our page looks like this. We've got 2 text boxes and 2 labels. Our last column we called website. So we just repeated the same thing 3 times. We've given each input a unique name and ID. And those names and IDs match the names of the columns in the database that each field is mapped to. Our form needs one more thing. What else does it need? It needs a submit button, because right now I can type whatever I want, but I can't do anything with it. So we will add at the bottom a button to save. We've added all the visual components we need. We are going to have to make 2 other small additions to this in order to get it to work the way we need it to. So load your form. What happens when you click the save button? Well, not quite nothing. Right. Why does the page reload? Okay. If we look at the URL, when I do that again, so when I save, my form reloads, and all of the values wind up being appended onto the end of the URL. So it did actually submit the form. Which page did it submit to? Yeah, it submitted to itself, which we don't want. So in order to prevent it from submitting to itself, we're going to need an action in our form. So instead of submitting to itself, we want it to submit to a save page that's going to process it. So if we add the action, it won't reload. If we try it again now, we've added the form action, what is the result going to be now if we submit? Right. So this is the expected behavior. An HTTP 404 status code page not found. It's trying to load saveartist.php. That file doesn't exist. Now we also want to deal with this problem. Leo, I'm going to ask you because you explained post and get before. So how come we have the values from our form being appended on to the end of our URL as parameters? Right. Well, it's actually not the action, it's a right. So even though we said earlier we're almost always going to use post, the default method for form submission is actually get. So if you don't specify that your form should use post, it will use get instead. Why is this potentially a problem? Why do we want to use get most of the time? What's wrong with displaying the form inputs in the URL? Exactly. It means anybody, maybe it's a password, maybe it's a credit card number. I mean, anybody standing behind can see. And also, when we use get and we have URL parameters like this, the browser history tracks them. So if you look in the history, somebody would be able to see any values that were entered, submitted in forms. So we don't want the URL parameters here. So to fix this in our form, we also need to explicitly set our method to be post. That will still send the values to our save page, but the values are not visible in the URL. So it's safer and more private. So add the method equals post attribute. And now if I refresh and save, the URL parameters are gone. So almost every form we ever use, we're going to use post. There's one common exception. We will typically see get used on forms like this. Whenever websites have search capabilities, those forms typically use get because we can already see the search terms in here anyway. It's not private. So we see them here. So I could even manipulate the search terms right here. I could just add on PHP plus MySQL plus HTML. And notice it modifies the query. So searching is pretty much the only time we're going to see get. So if we add an artist search into our website later, we might use get for that. All our other forms we're going to use post because of the enhanced additional privacy and security. I want to show you one very common mistake that probably everybody in the class is going to make with their form sometime during the semester, and that's this. What will happen now if I try to load my form and try to submit it? Let's see. So my form looks the same, and now my button does nothing. So in order for the form to be submitted, the button has to be inside those opening and closing tags. The button's outside, we're going to load it in the browser and our page is going to look fine, but it won't submit. So there's our quick check. If you click your submit button and nothing happens, the button is probably after your closing form tag. So our form is complete now. Now we need to deal with this. It's trying to load a save artist page that doesn't exist. So the quick way to get rid of this error is build this file. Even if it's a blank file, it will load. The 404 error will go away. So we need to make a file that has this exact name. So let's make a new PHP file called save artist.php. Now, even without writing any code in this page, I should be able to go back to my browser now, submit my form, and my 404 error should be gone. So if I just hit refresh, let my browser resubmit, it says, do you want to resend any action? I'll resend my form. Our 404 error goes away. We now have the save page that our form is calling. So in our save page, let's open up a set of PHP tags because we're going to need to write a bunch of PHP code in order to be able to take the artist name, the year founded, and the website and save those to our database. There's probably about 4 or 5 steps we're going to have to go through. Actually, I would say at least 5 steps we're going to need to do on this page. So let's plan the page out by commenting what the steps will be. We're not going to write any of the code yet. Let's just figure out the process. We have this form. We can put in a bunch of data. We're sending it to this page because we want to add the data in here. We want it to go into the artist table that we built in our database. So what things do we need to do on this page in order to make this whole process work if we were going to break it down one step at a time? What's maybe the first thing we would need to do to start the process? We will definitely need that. Yep. What else will we need to do? Yep. We might even want to do that first. So we'll save the form inputs one at a time to variables. That's an optional step, but it makes the code cleaner and less likely to, less bug prone if we do that. So we get our 3 form inputs, we connect to our database, whether it's our AWS database or our shared database. What would we do next? We will we'll actually have to do, so we do need to do that. That's the core feature of this whole page, ultimately, is send the data to the database we're connected to. We probably have to do maybe one other thing first. We're going to set up an SQL insert. It's possible to set it up and execute it at the same time, but it's messy. It's actually cleaner to break these out. First, set up the SQL we want to run with the values we want to save, and then execute it once it's all set. And then once that's done, after we've done all this, what's our final step? Okay, yep. And one more thing, I was thinking it actually was in that Word document. Yeah, we need to disconnect. Let's free up that database connection so another user can connect to the database or another request can connect. So this process is the same every time we're creating data in any table, in any web application for any reason. It's the exact same process every time. Get the inputs, make sure they're okay. We'll leave that part out for today. Connect to the database, set up the insert with the values, execute it, disconnect, give the user some indication that it worked. You can, but I'll show you why. At least with PHP, I would recommend, I'm always going to use variables. You can skip it if you like. But keep in mind, if you're working with the form inputs directly, here's the syntax. Let's say we got 10 values on the form. You've got to put $_post bracket quote value bracket quote bracket for every single one. So the margin for error is pretty high with this syntax. If we take all those 10 values and create them in variables first, we can then just do the data checking and validation as well as insert the variables. So you can do it with the form values directly. I don't recommend it. If you want to, no problem. But you'll probably spend more time debugging that way. So I'm always going to add this step. I'll say it's optional. So this doesn't matter if we are creating new users, adding anything whatsoever to a database. Here's the process. It never changes. The only things that change are what are the values, what database are we connecting to, what table are we saving to, and what are the names of the columns in that table. Those are the only things that ever change in this process. Everything else is the same over and over and over again. So it gets easy. A few people in my class yesterday, when we tried it, they got a little lost and they got overwhelmed. That's all right. We're going to do it again and again. So if it's not clear today, it'll become clear pretty soon. Okay, let's take a 10-minute break here. And I'm going to run and grab a coffee. When we come back, we'll write the code and we'll try and get artists saved to our database. I will push what we've done so far up to GitHub if you need it as a reference.